Hello, my name is Ian Sierra, and this is the Lab 2 video report. The purpose of this lab is to observe the motion of an object that is dropped from rest and falls straight down, which will be shown in Tracker. When creating one of the computational models, we will consider an aspect called drag force, which is a force acting opposite to the relative motion of any object moving. One model will incorporate drag force, specifically turbulent drag force, and the other will not. In our models, we will also incorporate the concept of Newton's second law, the equation for the gravitational force, and as stated earlier, drag force. In this lab, I decided to observe the falling motion of a tennis ball. In Tracker, I set up the orientation of the axis to be slightly to the right of the motion of the tennis ball in order to obtain a downward sloping graph, and the origin is at the center of the tennis ball. And now you will see the ball drop to the ground. And as a result of this, a line graph is generated right here that first starts off sloping down gradually and then becomes steeper as the ball continues to drop. Now, in the code without drag, I had to specify different aspects like the mass of the ball, the time step, and also the final time for the loop. Values for acceleration due to gravity and the J hat are necessary to calculate the weight force right here, along with the mass of the ball, and your weight force is in turn equal to your net force. And I also had to incorporate Newton's second law and the position formula. And as a result of this, we will run the code. And now the model is generated, showing the downward movement of the slope that first starts off gradual and then becomes steeper as it goes on. Now moving on to the with drag, I had to specify everything as with the first code, but now I had to specify a proportionality constant, which is the value, which is represented by the variable b right here, by basically doing trial and error to match up my final position in this model to the final position in Tracker. The drag force formula is also incorporated, but it was changed to the current form shown so that it could be proportional to speed squared, which is turbulent drag force. As you can see, the equation is Fd equals negative b times the magnitude of the velocity squared times the unit vector of the velocity. And the weight force plus the drag force is your net force. Also, two arrows are incorporated where one is the weight force and the other is the drag force. And now we will run the model. In this model, there are two arrows. The orange arrow represents the weight force and the blue arrow represents the drag force. The graph slope also becomes more straight as the line moves downward. It's more of a constant movement downward in this graph. In comparison, my experimental slope was not completely straight as is shown by this blue line on the graph, which could possibly be due to human error in Tracker, but as you can see, it is close in line with the yellow line, which is the model position with drag. The model without drag has a steeper slope, which is due to the only force being gravity, and the fact that there is a lack of resistance force that will be found with the drag force. This data shows that my falling object must have experienced drag force. The model with drag force predicts a terminal velocity, which is the constant speed a falling object has reached due to the resistance on the object. The model shows the slope becoming more constant as the object falls, as opposed to the model without drag, which becomes more steep. The ball was thrown downward. The terminal velocity will be greater than if it was dropped from rest, as you can see from this spreadsheet I generated. I created a computer code at first that has a starting downward velocity to indicate the ball being thrown downward. And as you can see, the fact that there is a starting velocity and another force added to it, that means that the fact of the ball being thrown down will have a greater terminal velocity than if it was only dropped.